So typically in a system of equations question, you would get either 3 equations or 2 equations, depending on how many variables they want you to solve for. For an equation that's solving for 2 variables like x and y, they'll give you 2 equations, but if you're solving for x, y, and z, they'll give you 3 equations. Today we're going to be working with a system of linear equations, so it will only be 2 equations, and we're looking for an x and a y. Of course, there are different ways to solve for it, and I'm going to explain how to solve for each. So first is the substitution method. So let's look at this equation. Y equals 2x plus 3, and then 2x plus 4y equals 42. The reason why we want to use the substitution method is because we already have the y isolated, and it would be easier to just use the substitution method. Now you may be asking, what is the substitution method? Well, the substitution method is when you take what one variable equals here, the y is equal to this, 2x plus 3, and we plug it straight into the second equation where we have a y. In system equations, if an equation looks like this, like y equals 2x plus 3, and one of the variables is already isolated, the y here, you want to plug it into the other one so that you can find it the easiest. So let's substitute and follow along with what we're supposed to do. So this is 2x, sorry, it's messy. 2x plus 4. Instead of a y, we're going to use what's in the first equation, 2x plus 3. This works because the system equation has to apply to both. For example, if I say y is equal to 2x plus 3 in the first equation in the system, then y has to equal 2x plus 3 in the second equation as well. So let's continue. 2x, brought the same thing, plus 4, put a 4, and then we subbed in the y from up here, 2x plus 3, and then equals 42. The next thing you want to do is you want to multiply it out and distribute. So let's try this. 2x plus 4 times 2x, 8x plus, if you want to keep the parentheses, you can always, because if there's a subtraction here, you want to keep things very neat. So 4 times 2x is 8x, of course. 4 times 3, sorry, is 12 equals 42. Since it's all addition, we can just add everything up. So this is 2 plus 2x plus 8x, which is 10x, plus 12 equals 42. Of course, we want to continue following the rules. So 12 minus 12 on this side, minus 12 on the other side, cancels out. 42 minus 12, 30 equals 10x. So let's bring it up here. 10x equals 30. Let's isolate the x. Divide by 10. Here we get x is equal to 3. Because 10 divided by 10 gives us 1x. Here we can put a 1. 30 divided by 10, 3. So here we found that x is equal to 3. And then we also want to know what y is because, of course, the system of equations question is not done unless we get both variables. So here we already solved for x equals to 3. So let's use the first equation again because it's the most simple. Y is equal to 2. Let's plug in what we already know x is. We already know x is 3, so let's put x in for 3 in for x, and then 3, and then y is equal to 2 times 3, 6 plus 3, 9. So we know y is equal to 9 now. If you're wondering if you can also use the second equation, of course you can use the second equation. Let's see what happens when we use the second equation. 2. Let's sub in the 3 plus 4y equals to 42. 2 times 3 is 6. Let's subtract out 6. Subtract out 6. We get 36. And then this becomes 4y equals 36 divided by 4. We get y equals 9. It's the same exact thing on top. So usually they also want it in coordinate form or like this. So you can either write, coordinates are always in format x, y. So we can do 3, because we know x is 3, comma. We know the y is 9, so we do 3, comma 9. Or we can do x equals to 3 and y equals to 9. So depending on what they want, you can answer it like this with a coordinate or like this. So let's try another way of solving for these. Now I have a new equation, so let's write that. 3x plus 2y equals 19. And then the second equation is 4x minus 2y equals 16. Here we want to use the elimination method because two things cancel out. It's not the x's because 3 plus 4x, it's going to give you 7x. But here if we add positive 2y, negative 2y, these are going to cancel out. So let's just add these two equations together. These will cancel out, and then we get 7x, because 3 plus 4x, 7x, equals 19 plus 16 is going to give us 35. Now we want to isolate the x, right? So let's divide by 7 on this side. So we have to divide by 7 on the right side. X is equal to 5. So now we know that x is 5. So let's go back to any of these equations. Let's do the bottom one. So let's just write down the original equation. The original equation was 4x minus 2y equals 16. Now let's plug in what we know is x. 4 times x, but we know it's 5, so let's put in 5 minus 2y equals 16. We continue solving for that. It's 20 minus 2y equals 16. But now we have to subtract out a 20 on this side, but that means we have to subtract out 20 on this side. So 20 minus 20, 0, minus, keep the minus, 2y equals 16 minus 20, negative 4. So we can get rid of this 0 here, because that might be distracting. What we always want is we want a positive 1 as a coefficient. So we want to not only divide by 2, but also by the negative. So let's divide by negative 2 on this side, divide by negative 2 on this side. What we get is y, because what we really get is 1, positive 1, y, but we don't really need to write that if we don't want to. Y is equal to negative 4 divided by negative 2. Two negatives being divided cancels out, so we get a positive 2. So now we know that y is equal to 2. So how would we write this question answer, you may be asking? We know x is 5, and we know y is 2. So we can write it like this.